example 4, here we have a string row set shown in this figure, was used to obtain normal string data at a point on the free surface. Okay, on the free surface of a plane component, then determine state of strain, state of stress at the point, and finally determine the principal stresses at the point. Okay, this is very practical. First of all, when you look at the free surface, okay, the free surface, you should realize that you will be dealing with a plane stress situation. Okay, then we do not need to use any algorithm for this example, since it has provided 3 steps. You just need to follow the steps and do them one by one. And eventually, you will get the principal stresses at the point. As we mentioned previously, finding out the principal stresses will be important, since that is the maximum possible normal stresses at this point. So you can compare it with the strength values then to determine if your designed component, structural element, is safe enough. Okay, so we can just solve these things step by step. In the first step, we will determine the strain state. Okay, so this is just something we learned last time to solve the strain row set. Okay, the equation has been listed here. We just need to determine the readings and the angles along these 3 directions. Okay, the readings have been provided here. The reading of the strain gauge A, strain gauge B, and the strain gauge C. Okay, you just need to find out their angles. Okay, the first angle, obviously, that is 0. Second angle, 135, and the third angle will be negative 90 degree. Okay, so at point A, our reading is 470, and the epsilon x times cosine 0. Cosine 0 here, the theta A equals 0. Cosine 0 will be 1. So here you get just times 1 plus 0. Sine 0 will be 0. Then plus another 0 here. Sine 0 will be 0. Okay. Then at point B, the reading is 120, and so epsilon x times cosine 135 degree square will be 0.5. Okay, then plus epsilon y sine 135 degree square will be also 0.5. Then gamma xy sine sine theta times cosine theta will be a negative 0.5, right? So here we will change the plus to minus 1/2. Okay, then at point C, the reading is 225. Then it's negative 90 degree. Okay, the cosine theta is 0. So here you get the first term 0 plus epsilon y, that will be 1, plus here, since the third item will include a 0, so it will be 0. Okay. So you can see that from the first equation, you can directly get that epsilon x equals 470 microstrain. And from the third equation, you would directly get epsilon y That is 225. So here you have only one equation left, that's equation 2. Okay, so from equation 2, you can just substitute the numbers in. You get 120 equals 470 over 2 plus 225 over 2 minus gamma xy over 2. Okay, it's easy enough to solve it. Right, so here the gamma xy will be 445 microradian. Okay, so here is the first step. We have just determined the state of strain at this point. Okay, summarize them. This will be, let's summarize them here. Okay, this is our first step, it's already done, or step A, already done. And to summarize them, you will get epsilon x is 470 microstrain, epsilon y 225 microstrain, gamma xy 455 microradian. Okay, then we can do the second step. Step B. In step B, we will determine the stress state. Okay, stress state. What we're determining here, as interpreted, we're determining actually sigma x, sigma y. Is there sigma z? Again, this is a plane stress. Okay, so no sigma z. Sigma z just equals 0. Okay, so then tau xy. Okay, these three components. We're determining these three components at this point. This is plane stress. From plane stress, we just use the plane stress equations. Okay, let's write it here. Plane stress. Okay, just recall the equations for plane stress. Then we use these equations to calculate stresses from strains. Okay, the first one would be sigma x equals E over 1 minus nu square sigma x plus nu sigma y. Epsilon x plus nu epsilon y. Right, so here you will have 175, the E, gigapascal, to megapascal. Okay, then over 1 minus Poisson ratio 0.25. Here you have 470 plus 0.25 times 225. Okay, do not forget microstrain. Okay, do not forget this microstrain. So the results will be 98.2 MPa. Then in the same way, sigma y can be calculated as E over 1 minus nu square epsilon y plus nu epsilon x. Okay, just repeat the previous step. I will just skip it. I will directly give you the result. That will be 63.9 MPa. Then the tau xy can be calculated. Just the same as the one-dimensional case, right? This is G, not one-dimensional. It's a two-dimensional case. So I can just we have just one equation. Okay, the G gamma xy. And here we do not have G. Again, you just need to recall the correlations between G, nu, and E. Okay, so here the G is E over 2 times 1 plus nu. It's 175 over 2 times 1 plus 0.25. 7 gigapascal. Or 70 gigapascal or 70,000 MPa. Okay, so using this, you can just calculate it. The G is 70,000 times 455. Again, do not forget micro. Okay. So this is important. Do not forget this. Important here too. Okay. Here you will have 31.9 MPa. Okay, now we have determined these 3 components. These 3 components to define the stress states at this point along x and y directions. Right? Just here the sigma x is here, sigma y here, and tau xy here. Okay, so eventually in the last step, we're determining the principal stresses. The principal stresses, if you remember the equations, it will be easy. You can directly write the equations if you have forgotten it. So thinking about Mohr circle, okay? From Mohr circle, you can easily recall this equation, okay? In the Mohr circle, the principal stresses will be the 2 points at the left-hand side and the right-hand side of the Mohr circle, okay? You can just start from the center plus and minus 1 times the radius, okay? So the principal stresses P1, P2 equals the center. The center will be the average of sigma x and sigma y, right? Plus or minus 1r. So the r is sigma x minus sigma y over 2. Okay, I'm not looking at any equation now, so I'm just thinking about the Mohr circle. Okay, you can also do it in this way to enhance your understanding of the Mohr circle. Okay, it's sigma x minus sigma y over 2 square and plus try to recall the height of that triangle. The height will be the tau xy. Okay, the tau xy square. Okay, substitute the numbers in, you will be able to find out the center and the radius. Okay, so here I would directly give you the result. The first principal stress would be 117 MPa, and the second P2 on the left-hand side of the Mohr circle, that will be 44.3 MPa.